All right, guys, today we're going to do geometric sequences. And please make sure that if you have not done so, or you may not need to, you can click on this link right here, and it will take us to our website that has all of our notes that we will need for today. Just an outline. It's very useful. You do not need to use this, but it will make things a little bit neater and more organized. So let's go ahead and go with today's notes. So we're doing geometric sequencing, and first let's write down our terms. Geometric sequence is a sequence in which the ratio between only two terms is constant, and a common ratio is the numerical ratio between any two terms, not and. It's a typo. So let's first take a look at an illustration. We have one trailer in the first time, two trailers in the second time, and four trailers on the third time. If we were to do arithmetic sequencing, we would go ahead and figure out what is happening. 1 plus what gives us 2, and this would be 1 plus 1 would give us 2. And then we would test it as 2 plus 1, and 2 plus 1 would give us 3, not 4. So it is not an arithmetic sequence. So let's look at our geometric. 1 times what gives us 2? Well, 1 times 2 is 2. And let's test it out. 2 times 2 gives us 4. So this one is good. On the trucks, 1 times 3 gives us 3, and 3 times 3 gives us 9. If this was an arithmetic sequence, we would have done 1 plus 2, which would have given us 3, and 3 plus 2, which would have given us 5. So we would have automatically have known that this was not an arithmetic sequence. So let's try to discover on how we figure out what our common ratio is. And our first example that we have today is 6, 12, 24, and 48. And we're just trying to determine 6 times what gives us 12. Now, ideally, if you know this, it should be 2, but if not, we're going to write a 6R, which is our ratio, is equal to 12. Then we're going to divide both sides by 6, and that means R is equal to 2. But we need to test it. So 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So yes, this does in case work. And then to find the next 3 terms, like it says in our notes, we need to multiply 48 by 2, which is 96. 96 by 2, which is 192. And 192 times 2, which is 384. Now we're going to do the next problem, number 2, but before we get to that point, I want us to remember dividing by 2 is the same as multiplying by 1/2. So we need to remember this. Multiplying by 1/2 does the same thing as dividing by 2. Dividing by 5 is the same thing as multiplying by 1/5, and dividing by 6 is the same as multiplying by 1/6. And we want to talk about this because our ratio, we only talk about multiplication. We do not talk about division. So if, for instance, in our next one, it is going down. So we have to divide. But to divide, we have to be able to, we cannot just divide. In this case, we divide by 3. We have to multiply by 1/3. But let's say you didn't know that this was 3. 810 times what gives us 270? Well, what would happen is that we could go to our Desmos calculator we've been using and type in we would type in 270 divided by 810. And as you see, it's going to give us a 0.33333. And we want to convert that, which this little button right here will make it go to a fraction. And that right there is our fraction, 1/3. So that is our common ratio. But we still need to figure out if that actually works or not. So we need to do 810 times 1/3, which is 270. And then we need to do 270 times 90. As my computer pulls up. Okay, so we say R is 1/3. Now, So in this case, yes, 270 times 1/3 is 90. Or we can type into our calculator 270 divided by 3. 90 times 1/3 or divided by 3 is 30. We need to find the next three terms. 30 times 1/3 is 10. 10 times 1/3 is 10/3. And 10/3 times 1/3 is 10/9. I am not concerned right now about any type of simplification in a factor. I am mostly looking right now to make sure that you understand what R is. Ideally, if we could simplify any of these, that would be fantastic for the nice practice, but I am looking more at what the ratio is and the final outcome. So let's look at the next one. This one's going to look a little different because we go from negative to positive to from negative to positive. When I see something like that, this automatically means that the number changes from negative to positive and back. This is a sign of multiplying by a negative number. Because what happens is that -2 gets multiplied by a negative, and a negative times a negative is a positive. A positive times a negative is a negative, and a negative times a negative is a positive. So that's how we know. So as soon as you see a negative, positive, we know that our ratio is going to be negative. Now, what I would do next is that I would actually do my ratios as in all of these were positive. So 2 times 5 would give us 10. And then I would test. 10 times 5 is 50. 50 times 5 is 250. So I know that my ratio is 5, but because it goes back and forth, I would set that as a -5. I could also do this the same way as doing 10 divided by -2, which we have done before. Now let's look at a different kind. 4, 8, 20, and 60. Now, 4 times 2 is 8, but is 8 times 2 20? Hopefully you didn't need to get your calculator out, but obviously, no, it's not. So if it's not arithmetic, it's not geometric, then right now, they do not have a common ratio, and we're saying that they are neither. We will talk about different forms later. Now what I want you to try to do is I want you to go ahead and I want you 5, 6, 7, and 8. And while that you got 5 minutes to do it, and then we will come back and do some more. All right, so guys, so now we're going to go ahead and we're going to switch over to the answer slide, and hopefully you have taking care of your answers. And let's take a look at this. So yes. And number 5, so the first thing we need to look at is that it's back and forth, right? Positive, negative, positive, negative. So our ratio has to be a negative number. And in this case, 4 and negative 1. The way we would do this is, right, we would divide it by 4, or in this case, we would times it by 1/4, and we would also make it negative. So 2, 4, 16, 2, 56. So in this case, 2 times 2 gives 4, but 4 times 2 does not give us 16. So this case, it would not work. Now, we would also normally check to see if it's arithmetic. 2 plus 2 is 4, but 4 plus 2 is 6, which is not 16. Now, the number 7 is what most people will get wrong because they'll see a negative and they'll automatically assume, well, the ratio has to be negative. But notice they're all negative numbers. Okay. So if they're all negative numbers, then don't worry about that. But negative 2 times what number gives us a negative 14? Well, that would be 7. Negative 14 times 7, that gives us a negative 98, and so on and so forth. And then here are our final 3 terms. Now, 3.2, 8, 20, and 50. So it's not always clear. So this one is a really good example of we need to figure out 3.2 times what gives us 8. And let's go to Desmos. So what we're going to do is we're going to do 8 divided by 3.2, right? And that gives us 2.5. Now, how did we get that? We basically stated that we wanted to do 3.2 R is equal to 8. Okay, and that's all we have. So let me change this back to X. Okay, so 3.2x equals 8. And then lo and behold, if we were to actually have done this, you can see that right here, what is that number? That is 2.5. So that's the only number that it works. This is how you do it graphically if you need to. And then we go back and we check that. Does that actually work? Does 8 times 2.5 give us 20? And let's just test it out. What is 8 times 2.5? What does that give us? It gives us 20, and then we can continue on. What is 20 times 2.5? That gives us 50, and in this case, it works out perfectly, and we can continue. Okay, if you have any questions on this or you need to rewatch the video, please do so now. I'll be more than happy to answer questions. The next thing that you need to do after this is you need to go onto our website and you need to go into our chapters. We want to go down to sequences and series. Try this again. Sequences and series. Geometric sequence. And go to homework. Our homework is on here, and go ahead and start doing the first page. And we shall review the first page with everybody on our next video, and then continue on after that. You can print this off and scan it into Google Classroom, or you can write a sheet of paper, take a picture, and then send it in via Google Classroom or via email.